In set 1, number 8, you're asked to solve, in these instances, each linear equation for x. Now, in each instance, you have to isolate x so that you've just got an answer that says x is equal to something. In each instance, see what is next to the x and ask yourself, how do I undo it? And because you're fair and reasonable people, we'll undo it to both sides. In A, I've got a -5 that's stopping x being by itself. A +5 undoes the -5. Adding 5 to both sides gives me x is equal to 8. In D, what I've got here is a +2. Ask yourself, what undoes +2? I'm going to take 2 from both sides. In J, I'm really after what the opposite of -x is. If you like, I can divide both sides by -1, and x is equal to -5. In M, a question like this, if you ask yourself, what do I multiply 3 by to get 12? You'd say 4. And you'd be right. I just want to show you a tactic that we can do where perhaps you don't have a whole number that multiplies in. In this case, this is a 3 times x, so I'm going to divide both sides by 3. And that in turn gives me x is equal to 4. When it comes to P, I've got 7 times x is equal to -21. The opposite of multiplying by 7 is, so I'm going to divide both sides by the 7's cancel, and I'm left with 7 into -21 or -3 as my answer. In question 9, you're dealing with having to transpose not only one operation, you're using one operation, but also 2. In the first instance, we're after what x is, as the second, third, and the fourth ones I've set. The first thing you've got to do is to isolate the term with the x. Now, in the first instance, I've got a +5. Now, I undo a +5 with a -5. Now, at this point, you might say, well, hang on, x is equal to 6. Just to check that, I'm going to divide both sides by 2, and I do end up with x is equal to 6. Do one thing at a time, please. In D, I have a -8, blocking the 2x term. Ask yourself, what undoes a -8, and then do it to both sides. And then, I'm not going to divide both sides by 2 because I can see that x is going to equal 3. When it comes to G, I have to undo a -5 first before I can then tackle the 6x. So that's adding 5 to both sides. Now clearly, this is not something everyone's going to be able to do in their head, so I do have to undo both sides by dividing by 6. So it becomes x is equal to 7n over 6. You can either convert that to a decimal, usually to 2 decimal places, or leave it as such. In J, I'll work it through. See if you can see what I'm doing to both sides as I work this through. Now, in this instance, I've got x divided by 2 is equal to -12. I'm now going to multiply both sides by 2, cancelling the divided by 2, and that gives me -24. I'll just plod through the next two, see if you can follow the processes as I work along. In P, I've got a left-hand side with 8x and a right-hand side with 3x. Now, I just want to have one side with x's. What you do in these instances is to remove the x's where there are fewer of them. So I'm going to take 3x from both sides. Still looks a bit messy, but I can still progress through. Remember, I'm isolating the x term. Dividing by 5. Now the last example, S, once again has x on both sides. Clearly, there are more x's on the left-hand side than there are the right-hand side. So I'm going to undo that minus 2x. Think to yourself, what is the opposite of minus 2x?